This is not electricity. You can't see electricity, you can only see its effects, such as light, heat, motion, magnetic fields, very expensive bills, and electric arcs. Take this simple circuit with a battery, a switch, a lamp, and a wire connecting them all together. The battery is adding energy to the circuit, and the lamp is removing this, transforming it into light and heat. We can flip the switch to control this. What's happening is tiny particles called electrons are moving through the wire from the battery's negative terminal through the lamp and into the positive terminal. They actually move a very small distance, but I'll explain that in just a moment. Many of us were taught that electricity flows from the positive to the negative. That's because long ago, Benjamin Franklin theorized that electricity was an invisible fluid. He rubbed a glass rod with a cloth, which then gave him a shock. He believed the cloth was adding more of this fluid, making it positive, while the person touching it had less, which made them negative. So he assumed that electricity flowed from positive to negative. Schools then taught this information, many still do, and we call this conventional current. Some years later, Joseph Thomson experimented with a cathode ray tube, a device with two metal plates in a vacuum. When powered, a strange ray appeared, and it oddly traveled from the negative to the positive side. He observed that a magnetic field influenced the ray's direction. He also noticed that when passed between electrically charged plates, it deflected in the electric field between them towards the positive side. As we know, like charges repel and opposites attract. So the beam must be made of tiny particles with a negative charge that moves from negative to the positive. He called these particles an electron, and we call this electron flow. Unfortunately, Benjamin Franklin had guessed incorrectly. The cloth was removing electrons from the glass rod, and they were moving from the person to the rod. The common analogy is that the battery is like a pump, providing the pressure to push the current through the circuit. We measure this electrical pressure in the unit of volts. For example, this battery is rated to provide 1.5 volts, and this one is rated for 9 volts. The water flowing through the pipe is similar to the electrons flowing through the wires. We measure the flow rate in quantity per time, and we measure the current in amperes, or just amps. 1 amp is equal to 1 coulomb per second, which means that if 1 amp was flowing through this wire, then we would have 1 coulomb of charge per second passing this point. An experiment by Robert Millikan calculated the charge of an electron, which is a tiny number. But from that, we can calculate how many electrons are flowing, and we see that 1 amp is equal to around 6.2 quintillion electrons per second. So we just say 1 amp to make it easier. The lamp is adding resistance to the circuit, similar to a section of thin pipe, limiting how much water can flow. We measure the resistance in the unit of ohms. So the voltage is the pushing force, which moves the electrons, and the resistance makes it difficult, so it limits the amount of current which can flow. But we can use Ohm's law to calculate the resistance, voltage, or current in a circuit as long as we know two values. So if we measure the current in this circuit and we know the voltage, then we can easily calculate the resistance. From that, we can calculate how much energy is being consumed. So where are these electrons coming from? Well, they are already in the wire, although some do come from the battery. The wire is typically made from copper, which is just a structure of many tiny copper atoms. Atoms are so small that this cubic centimeter of copper contains over 84 sextillion atoms. So this wire contains a lot more. An atom is just a collection of 3 particles, the electron, neutron, and proton. Different elements have different numbers of these particles. These elements are listed in the periodic table, and here we can see copper. I'm going to use the Bohr model to illustrate the atom, but some of you will be familiar with the more accurate quantum mechanics model of an atom. This is very complex and beyond this video, so we're going to use the Bohr model. This shows that the copper atom has 29 protons and 35 neutrons at the center, which forms the nucleus. It also has 29 electrons around the nucleus in different orbital shells. In the outermost valence shell, there is one electron, which is free to move around to other copper atoms. Due to ambient thermal energy, these electrons will naturally move around. They are mobile, and they move randomly in any and all directions. These mobile electrons are bouncing off of atoms and ending up roughly where they started. While some move left, some move right, so the average is 0. The electrons are negatively charged, and the protons are positively charged. Neutrons have no charge. When an electron leaves the atom, there are more protons, so it has a positive charge, and we call this an ion. The copper atoms are all sharing electrons, so inside the wire we have the same number of electrons and protons. Therefore, it is balanced and no charge exists inside the wire.